Today's video will demonstrate how to access elements from the map using the subscript operator as well as the @ operator. Hello, I'm James Helfrich. The most powerful method, perhaps, of the map is the subscript operator, otherwise known as the square bracket operator. There's a companion method called the @ method. This video will demonstrate how both of those work. One of the most powerful and useful methods of the map class is a subscript operator. There are two variations. The first one takes a key constant by reference and returns a value by reference. The second is the move operator. And this is useful when I want to add a new element to the map, and then I want to take the key and move that into the map. The second is the @ operator. The difference between an @ operator and a square bracket operator is that the @ operator will not create a new element if one does not exist with the current key. Notice how we have both a non-constant version, which means I'm allowed to change the value, and a constant version, which means the value and the key must remain unchanged. Let's demonstrate how this works. First of all, I'm going to create a map with 3 elements. So I'm going to have D is 500, C is 100, and L is 50. This is a mapping, of course, from Roman numerals to regular numbers. Now, if I say cout M of C, let's see here, what's the value of C is 100. And so the map will not change, but I will get 100 on the screen. Then if I cout map of X, well, X does not exist. And so a new element is created. And then I'll put 0 on the screen because the default value for an integer is 0. Then I'll say map of X. X is now set to 10. So it will change from 0 to 10. And then I'll say cout at X. So I'm going to take a look at the value of what's at X, and that's 10. And then I'm going to try to say @ of V. Unfortunately, V does not exist in the map. Now, with the square bracket operator, we'll add a new element. With the @ method, we won't add an element, but instead we'll throw an exception. To demonstrate how this works, we'll go into the debugger. Now, in order to use the map, I have to say #include map. Now I can create std::map, and what am I going to make a map of? I have to have the key and then the value as 2 template parameters, so I'll say a string and a float, and I'll call this M. Well, if I'm going to use a string, I better #include a string as well. Now, I don't like the std::, bit, so I'm going to use a shorthand using namespace std, and this allows me to use the short version of map. So now I'll be able to say map string float, not std string or std map. Okay. Now what I like to do is I like to add an element into my map, and I'm going to insert a pair, and the pair would be the key value pair, and this would be a string and a float, and I'm going to add pi as 3.14. Okay. Now we want to see how this looks, so I'm going to set a breakpoint at the end, and when I run this, I'm going to get my map. There it is. And notice how I have a key is pi and my value is 3.14. Okay. Now I can use the square bracket operator to insert an element into the map. So in this case, I'm going to insert E, and that would be 2.7. When I run the debugger, we're going to see that I can have the value added into my map. So now I have both pi and E. I don't know about you, but I think the square bracket operator is way more convenient than the insert with the pair business. So I'm going to use that from now on. Now I can retrieve the value by saying G equals M of G. Now notice how G does not exist in my map right now. I don't have a key named G. And so when I look at this, we're going to see that a new element was created. And that new element has a default value for a float, which is 0.0. So now I have 3 elements in my map, not 2. Let's take a look at the pseudocode for the subscript operator. I'm going to take a key as a parameter, and I'm going to return the value. Now, first of all, I'm going to try to create a pair because remember, the underlying data structure of the map is a binary search tree where every node is a key value pair. So I'm going to create a pair with the key as the passed key and the default value for value. And I'm going to try to find that in the BST. If the iterator is not the end iterator, then I'll return it.second, which corresponds to the value. Otherwise, I'll insert that pair into the binary search tree. So let's take a look at how this works. I have a string integer map called numbers. This counts for phone numbers. And I'm going to have an operator is 0, police is 911, and his Jenny is 8675309. And I'm going to insert operator, and I'm going to insert police, and I'm going to insert Jenny. Now notice how the keys are always in sorted order because the underlying data structure is a binary search tree. Then I'm going to say, hey, what is the phone number for the police? And when I go into my pseudocode, we'll see that the iterator is not null, so it.second is returned. Then I'll say, what's the phone number of directory? Well, directory is not in the binary search tree. So therefore, we're going to add a new node into our binary search tree, and we're going to add directory there with a default value for integer, which happens to be 0. Then I'm going to set directory to 5551212. So this is going to modify the value of directory to 5551212. And then I'm going to look for Alicia. And I'm also going to assign the value because remember, the subscript operator returns the value by reference, which means I'm allowed to change it. And not only will a node be created for Alicia, but the phone number 489-4608 will get added. Let's take a look at the app method now. This will work the same as a subscript operator with one important difference. Instead of adding an element, if one does not exist, we're just going to throw an exception. So I'm going to create the same key value pair that I did before, where value is the default value for my template. I'm going to look for it using find. If it exists, then I'll return the second, but if it does not exist, I'll throw. So my code will look the same as it did before. I'm going to insert operator and police and Jenny. Now I'm going to use the at method to look for police. Now notice police is in the map, so I'm going to get 911 in number. Now I'm going to look for directory. Notice directory does not exist. If this was a subscript operator, I'd add a new element to my map, but it is not. It's the at method. So instead, I'm going to throw an exception. Okay, here's an exercise for you. Pause the video and see if you can predict the output of this code. First, I'll add a C Charlie value. Then I'll add a B Bravo value. Notice how Bravo comes before Charlie because B is before C in alphabetical order. Then I'll do a D Delta, and D is after C. Then I'll say an A Alpha. And when I iterate through the map, it's going to go in alphabetical order. It's going to first do the key, which is A, B, C, D, and then I'll do the value, which is Alpha, Bravo, Charlie, and Delta. Here's a second exercise. Again, pause the video and see if you can work this out for yourself. Okay, I have an integer char map, and so I'm going to add 33 to Z. I'm going to add 67 to X. I'm going to add 26 to W. Notice how I'm sorted by key, not by value, so 26, 33, and 67. Then I'm going to try to compare M of 26, which is W, with M of 13. Well, M of 13 does not exist, so a new key value pair is going to be added with a default character, which is 0, or the null character. Now, 13 is before 26, so it comes before it in order. Now, I'm going to compare the null character with 26, which is W. They are not the same, so I'm not going to go inside the body of the loop. Now, when I output the result, I'm going to get 13 null, 26W, 33Z, and 67X. That empty 13 is probably the trick, isn't it? You can learn more about the access methods in the map chapter of the C++ data structures textbook.